Hi everyone! Today I will introduce to you all about mushroom packaging. Mushroom packaging is made from mycelium foam. This is mycelium. What is mycelium? Mycelium is the root network of a fungus usually found in the ground. The fungus-based form is being used instead of expanded polystyrene as an alternative packaging material.
The first principle is to prevent waste. Mushroom packaging was made from mycelial tissue and agricultural waste, in these cases, crop waste such as corn husks, sugarcane barges, and rice husks. All of this would then result in a zero waste product. Why? First of all, let me tell you that this product was actually an alternative product for styrofoam or polystyrene. True to its name, polystyrene was made from a polymerizing styrene that used a phenol on it. All of this make there is a chemical bond and a chemical reaction inside of one product that make it non-biodegradable and non-recyclable. According to a research done by Washington University, it takes about 500 years in order for a styrofoam to decompose. This is why landfills is full of it. There's so much waste and most of it comes from styrofoam. However, it's different with mushroom packaging. As it was made from a natural ingredient, it could become a compost and go back to the nature. That's why this product is indeed preventing waste.
So the 10th green chemistry principle is to design chemical and product to degrade after use. So how is it applied in the mushroom packaging is that our product is made out of mycelium foam, which is completely biodegradable as it is an organic substance or an organic product. So this property is highly desirable for single-use applications such as packaging, and it can even degrade in the natural environment and return nutrient into the soil. Furthermore, it is also fully degradable in 30 to 45 days as compared to styrofoam, the product that we usually use now, which may take forever due to its plastic nature. So anyone who receives their products in this mushroom packaging can simply just throw out the packaging at their garden or their backyard, and it can act as a natural fertilizer.
Next principle is less hazardous chemical synthesis.
Styrene is an aromatic hydrocarbon which is colorless and vaporized easily. There was a study where air samples were collected based on NIOSH 1501 method and analyzed by variant CP3800 gas chromatograph. In these studies, it shows that the workers in plastic packaging factories that are exposed to styrene vapor have definite cancer risk by 16%. This is very dangerous for the workers. On the other hand, by using mycelium foam, there is no exposure to toxic gases, so there is less cancer risk to workers.
The fourth principle of green chemistry is sever chemical and product. As stewards of this planet, it is our responsibility to explore sustainable alternatives, and today we will dive into the innovative world of mushroom packaging. So, what is this mushroom packaging all about? Imagine packaging material that is not only sturdy and versatile, but also environmentally friendly from production to disposal. Mushroom packaging derived from mycelium. The root structure of mushrooms is an extraordinary example of sustainable innovation. Mycelium foam are natural and non-toxic materials, so it is safer for human health and the environment because fungi is natural and renewable source of valuable polymers such as chitin and quercetin, while traditional packaging materials such as plastic is made from synthetic polymers may contain harmful chemicals like BPA, and it will lead to cancer. From pollution to waste, these materials have far-reaching consequences, so it's time for change.
Safer solvent and reaction condition. Most conventional packaging are using styrene. In the manufacturing process, styrene need to undergo expanding process using blowing agents such as propane, CFCs, and pentane. However, these blowing agents are harmful to the environment. For example, pentane poses flammability hazard, and CFCs can cause depletion of ozone layer. With the product mycelium foam, there is no expanding process. It only has cold or hot pressing process to prevent further growth of mycelium.
This is increasing energy efficiency. Mycelium unit product production heavily consider environmental impact with its overall energy usage being offensive utilized in most of its life cycle. Ensuring that the environmental conditions for mycelium growth include temperature, humidity, and air quality. Power mycelium cultivative process with renewable energy sources like solar, wind, or hydroelectric power to minimize the carbon footprint. Invest in research to develop more energy-efficient production processes, including strain selection and genetic engineering.
The seventh principle is use renewable feedstock. Styrofoam was made from a polymerizing styrene, and its main medium would be styrene and a liquid hydrocarbon. Thus, it's more on the chemical side as its main medium. However, our product was made from organic material, which is mycelia tissue. Mycelia tissue make it no need for us to use any type of glue or a chemical thing in order to make it stick together, as mycelia tissue would groove together along with another medium such as crop waste and make it one product inside the mold.
8 is avoid chemical derivative. Substrates used to grow mycelium, such as agricultural waste product, typically require minimal chemical derivative. Consider sustainable pretreatment can use of mild acid, biological pretreatment, or less toxic chemical. For nutrient optimization, look for natural sources of essential nutrients such as nitrogen and phosphorus to reduce the need for chemical derivative. Also, mycelium substrates may undergo sterilization or disinfection, but efforts are made to minimize the use of chemical sterilization.
The ninth green chemistry principle are the usage of catalytic reagents. As we go through our research, it is found that the mycelium growth and its initial cultivation took a long time to be done, which took almost 2 weeks. And this is obviously not ideal given that the need for swift production to meet the product demands. Recognizing the urgency of the situation, we conducted research into potential catalysts that can be used to fasten this process. And our focus turned to glycoside hydrolase, which known as GH and also GT. GH, which is a major group of CA enzymes, plays a crucial role in catalyzing the glycosidic linkage within polysaccharides. Also, the increase of beta-1,3-glucan synthase production, as well as its overexpression using promoter swapping, seem to be a promising alternatives to address the time constraint and elevate overall efficiency of mycelium cultivation.
So for the second green chemistry principle, it is maximizing atom economy. Basically, what atom economy means is that it is a measure of the amount of starting materials that ends up as useful products. So for a good product, it has a high atom economy. So in mushroom packaging, the atom economy is maximized as there is zero byproducts from the production process, and as compared to the usual products that we use, such as styrofoam, which produces harmful byproducts such as toluene, benzene, and also hydrogen.
Now, for the 11th principle of green chemistry is analyze in real time to prevent pollution. What we use to analyze in real time? So we design and build a fully customized green tent. This is it. Meticulously designed to offer proper thermal and humidity in the tent for mycelium growth. Our goal is for the green tent is to provide us with complete control over the temperature and humidity levels within the tent. We integrate an Arduino chip to monitor and regulate environmental data to achieve this effect. Moreover, the Arduino chip can help us to record the data for analysis. An Arduino Mega 2560 circle with sensors is used to monitor the temperature, humidity, and carbon dioxide levels of mycelium growth. The scanning frequency we use is 115 and 200 Hz, accuracy of temperature sensors 0.5 Celsius degree, accuracy of humidity sensors 0.1% of RH, gravity infrared carbon dioxide sensors is using resolution of 1 ppm. Electric device for heat and humidity generation is using two of the heat mats provide enough heat in the green tent system. They are installed on the back wall center area. The iPower GLHT MTM durable waterproof seedling heat mat has a size of 20 inch by 20 inch and the target temperature control range is 40 to 108 Celsius degree. The operating power is 96 watt for two heat mats. We use an irregular ultrasonic humidifier in the green tent to tune the humidity level inside. The humidity has a 4 liters water tank with 210 mil H1 maximum mist output, and it is controlled by the humidity sensor and only be turned on once the humidity level drops 90% RH. The average water consumption is approximately 1.5 liter per day. The water in the humidifier is filtered by an external water filter.
The last principle of green chemistry is to minimize the potential for accident. As we journey towards sustainable alternatives, it is crucial to understand how innovation like mushroom packaging not only benefit the environment but also contribute significantly to minimizing the potential for accident. So, what makes mushroom packaging inherently safe? Firstly, it is non-toxic. Unlike certain traditional packaging materials, mushroom packaging doesn't introduce harmful chemicals into the environment or during its production. This inherent safety feature is a direct result of green chemistry in action. Beyond environmental safety, mushroom packaging also contributes significantly to workplace safety. The production processes of mushroom packaging are designed with worker safety in mind. By minimizing the use of hazardous materials, the risk of accidents in manufacturing facilities is substantially reduced, aligning perfectly with green chemistry's commitment to human health and safety.
In summary, the reasons that we choose mushroom packaging as our product is because it is not only emission-free, but it is also non-toxic, comes at a low cost, and can be recycled. So, it is definitely the better option for our planet in the long run. This makes a better choice, especially if you compare it with the traditional materials that we use, such as polystyrene and styrofoam, which harm the environment and takes ages to be broken down. And as I mentioned before, there are certain criteria that get in the picture when we want to choose the fungus for the mycelium foam, which most researchers agree that fungus species belonging to the phylum Basidiomycota, such as Pleurotus astratus and Ganoderma lucidum, show better results in composite production. Considering the trend of online shopping that is only going to increase, it is expected that the demand for packaging will significantly increase too. So, opting for mushroom packaging is a strategic move to help save our planet from excessive waste. It is a small change that can make a big difference in the long run.